Good afternoon, everyone. Thanks for joining us this afternoon to learn about Presto at Pinterest. In this talk, we will be talking about Presto, how it is used at Pinterest, the challenges we faced in our journey to happy querying with Presto at Pinterest, and more importantly, how we solve those issues. However, let's start with the most important thing first, which is about me. I'm Ashish Singh. I'm a tech lead on Big Data Query platform at Pinterest. I've been with Pinterest for almost 4 years, trying to make querying at Pinterest a happy experience. Prior to that, I was at Clara working in a similar space. Now that we know enough about me, let's get started. At Pinterest, we build world's catalog of ideas by helping people discover and do what they love in reality, like fashion, travel, design, cooking, etc. I'm pretty sure we all know about this. But to enable Pinterest to do so, we rely on scalable, efficient, and reliable data processing. Pinterest is a data-driven company, and so these capabilities are really critical for the business. Data processing capability is important, but ease of expressing computational needs is equally important. This is where SQL comes in. I'm sure the audience here gets most excited by scalability challenges. So let's take a look at some of the scale numbers at Pinterest relevant to this talk. It's only fair to start with business scale. At Pinterest, we have over 400 million monthly active users, over 200 billion pins, and over 4 billion boards. Let's see how that business scale translates to scale of data. We have over 400 petabytes of data in AWS S3. We run close to 100,000 Hadoop jobs per day on multiple of tens of thousands of Hadoop nodes. More relevant to this talk, we have over 500 nodes serving Presto queries that enable queries querying from hundreds of thousands of Hive tables. We have all of our offline data sets on AWS S3, and all of our compute instances are on AWS EC2. Before we talk specifically about Presto at Pinterest, let's take a look at brief history of how query and data platform evolved at Pinterest. It was not until 2016 when we started exploring Presto. Before that, our interactive querying needs were served by AWS Redshift. We started exploring Presto while building our in-house data platform. As of 2018, we have a completely in-house maintained and operated data platform, and Presto is a critical piece of it. We are looking at Presto's monthly active users and weekly active users over time. We have close to 1,500 monthly active users, which is pretty close to our employee strength, which essentially means that we have almost all of our employees across all the orgs, including non-engineering organizations, using Presto. The popularity of Presto can easily be attributed to its speed in finding answers from petabytes of data. Presto serves over 1 million queries each month at Pinterest, and number of queries and use cases that are served by Presto continues to rise. Let's look at Presto deployment at Pinterest. We have multiple Presto clusters, each serving a particular category of queries. For example, we have a dedicated clusters to serve predictable query patterns like scheduled queries. We call them app clusters. Some are more meant to handle bursty traffic patterns like ad hoc queries, which are simply called ad hoc clusters. All these clusters are behind a service known as Presto Gateway. This service helps keeping clients oblivious of various Presto clusters and provides critical functionalities that we are going to talk about in next 2 slides. Each cluster has capability to have dedicated workers and transient workers on a Kubernetes cluster. We have another service known as Presto Controller that helps maintaining a watch on various clusters and perform admin level tasks. We are going to talk about that service as well in the next few slides. Users query from places like Hive tables, MySQL, Druid, and some Thrift services. However, majority of the use cases query from Hive tables that points to data on S3. While querying from Druid, we query directly from the Druid segment files and avoid putting any extra load on Druid servers. As I just mentioned, Presto Controller is one of the critical pieces of our Presto deployment infrastructure. It's an in-house service which is critical to our Presto deployments monitoring and self-healing. It serves major functionalities like health check of individual clusters, slow worker detection, heavy query detection. It also handles like when it detects heavy queries, which essentially kill them, rolling restart of the Presto clusters, and scaling clusters when we have a need to do so. Presto Gateway is another service that sits between clients and Presto clusters. It essentially is a smart HTTP proxy server. And because it is stateless, it's very easy for us to scale it up or down. We use Presto Gateway to route queries to different clusters based on rules. And these rules we control dynamically. So we can handle the traffic based on available clusters and the incoming load very dynamically. For example, if we see that, there's a query, a source which is becoming more active, and it's overflowing, or like it's going beyond the resources available on a particular cluster, we can start routing those portion of those queries from that source to other clusters as well. We also provide resource usage visibility for users, organizations through Presto Gateway. And we also provide overall cluster health visibility to our users and for various SLA calculations through Presto Gateway. There are a few more things, few more services delivered by Presto Gateway that we'll be talking about in the following slides. This is a screenshot of Presto Gateway. As you can see various backends or various clusters behind this gateway, various resource groups, and we'll be talking about the resource group part a little bit more. But it gives you a very good view of various clusters that are serving queries. In this case, ad hoc queries, just on one page. Let's take a look at the various Presto clusters that we have at Pinterest. Our Presto version is based off Presto SQL version 320. We typically use Hive, MySQL, Druid, and Thrift connectors, but most of our use cases are on Hive connector. Ad hoc workers, we have them running on Kubernetes pod, whereas app or scheduled cluster workers are running on dedicated instances. We have in total 5 clusters and around 500 workers distributed between these clusters. Our coordinators are roughly around 488 gigabytes in memory, 64 cores. Our workers are between 340 to 384 gigabytes of memory and between 43 and 48 cores. Now that we looked at the overview of Presto at Pinterest, let's take a look at the challenges we faced and how we solved them. Let's start with one of the primary issues we faced at Pinterest while onboarding Presto. This was caused due to very large nested Thrift schemas. In Presto, a coordinator fetches table schema and then sends over the serialized schema as part of each task request. This design has the advantage that prevents Hive Metastore or any service serving schemas to not get bombarded with requests from workers. However, this leads to overwhelming of network and coordinator memory. When schemas are very large, this can easily happen, which was the case for us. Thrift schemas are a primary way of defining and maintaining schemas at Pinterest. We also support users to create Hive tables by just pointing to a Thrift schema. We support all the schema evaluation rules supported by Thrift schema on Hive tables as well. This makes it very easy for people to define new schemas and then use them from end to end, like in the online services and for offline data processing as well. However, with Thrift schemas, it is very easy for schemas to grow in size. Over a period of time, Thrift schemas at Pinterest have grown significantly and has challenged various components of our data platform to rethink schema handling, including Presto. We distribute Thrift schemas at Pinterest as jar artifacts. These jars are distributed and loaded by all services that need to access these schemas. In Presto, coordinators and workers all have these jars loaded during startup time. This made us think that why do we even need to send these large schemas as part of task requests? We modified task requests to replace serialized schemas with just Thrift class names and made workers reconstruct Thrift schemas from Thrift class names. This solved a bunch of issues we were seeing along coordinator out-of-memory errors and increased our Presto cluster throughput tremendously. The next issue we struggle with is bad workers in Presto clusters. Presto gains a part of its efficiency and speed from the fact that it always has JVMs up and ready to start running tasks on workers. A single JVM is shared by multiple tasks from multiple queries on a Presto worker. To ensure slow tasks aren't slowing down all the tasks on a worker, Presto uses multi-level feedback queue. However, this leads to scenarios where slow tasks can accumulate over time, as quick tasks would be prioritized and will finish quickly. IO tasks are a good example of slow tasks that can accumulate on a worker. With all data on S3 and the fact that S3 throttles down requests when a prefix is hit hard, leave tasks can easily slow down. Slowness easily spreads from a slow worker to other workers waiting on the pages from the slow worker. And slowly, entire clusters throughput gets down to 0. We used to see this very frequently, sometimes 2 to 3 times a day. And the solution we had at that point, just restart the coordinator, which means killing all the queries. Not a happy querying place where we want it to be. Solving this problem requires a good mechanism for detecting bad workers and a fair resolution mechanism when a bad worker is detected. To detect a bad worker, we look at following criteria. If a worker CPU utilization is lower than cluster's average CPU utilization. If lots of queries are failing with internal errors, indicating failure while talking to a particular worker. If a worker has open file descriptors higher than a threshold. We had to tune these thresholds a bit to get this right. When any of these criteria are met, a graceful shutdown is first attempted. However, failure to gracefully shut down a worker in a few attempts will lead to Presto Controller we talked about, forcibly terminating the EC2 instance for dedicated workers or shutting down the Kubernetes pod for workers hosted on Kubernetes pods. While talking about Thrift schemas, we mentioned the need for restarting clusters. There are many other similar dependencies which rely on cluster restarts. These dependencies make need for cluster restarts an important operation. We restart Presto clusters each night due to these reasons. However, to support seamless querying experience, graceful shutdowns and controlling query traffic is what we rely on performing cluster restarts. We utilize Presto Controller to perform rolling restarts of clusters and Presto Gateway to control query traffic. Most of the organizations who operate Presto at large scale have similar solutions. Even though we support Graceful cluster restarts, we still try to avoid cluster restarts as much as we can, as cluster restarts mean lower throughput overall. Apart from the need to avoid restarting clusters, we also want to ensure that same version of dependencies are loaded on coordinators and workers. To do so, we version the jars and include version in the node infos of coordinator and workers. We broadcast coordinator node version to all workers. We restart a worker only if jar version does not match with coordinator's advertised version. While restarting, worker pulls the right version, right jars for that particular version as broadcasted by the coordinator. So far, we only talked about improving system. However, a lot is there to be achieved by enabling users to write better queries and enable them to diagnose issues with their queries in time. For that, we utilize Presto Warning system. We utilize that to deliver recommendations to our users as soon as possible, which means real time. As soon as one of the criteria are hit, we let the users know, oh, your query is doing badly or performing poorly because of this reason, or your query failed because of this reason. These warnings can be divided in two categories. One is query authoring, and the second one is query diagnosing. Some examples for query authoring warnings would be if a user doesn't specify a partition predicate while querying from a partition table, we throw a warning and ask the users to seriously think about using a partition predicate. If the user is querying a very large amount of data set, like hundreds of thousands of rows, we ask them to limit the number of output rows. Similarly, for query diagnosing, we have warnings that gets thrown when, for example, someone is querying from a table which is not using columnar file format and is querying from something like text or sequence file. And we encourage them to use columnar format version of the table. Or if we see that there is a very high CPU consumption and or the user did not specify the right source script config, we again remind them or ask them to fix those kind of information as soon as we detect that's an issue. Those were just some examples. We are building on these warnings, and we are trying to improve upon, make our users better educated. And in the process, we are trying to reduce the support load on the platform team. This is a screenshot of one of the clients that we have. It's called Data Hub. It's recently open sourced. And you can see the warnings here. So when a user is running the query, while the query is running, these warnings, they come in and the users can see, and they can decide to even kill the query and then restart with after addressing these warnings. But this definitely improved the type of queries we are seeing, definitely reduced the query failures due to user errors, or in some cases reduced our query failures due to insufficient resources, and things like that. So we are really optimistic about the opportunities this opens up to work very closely with our users without answering the same question again and again for each and every individual user. With diverse use cases being powered by Presto, the query patterns and their resource requirements are very diverse too. How to best serve those queries efficiently remains a challenge that we continue to strive to solve. Time-based variants are majorly seen on ad hoc usages. However, even for scheduled use cases, the users tend to have durations on peak usage. It's very common for people to schedule their jobs to run at UTC 0, for example. We route traffic between different clusters, even ad hoc and scheduled clusters, to handle the traffic variance that's based on time. We still try to maintain the SLAs for our scheduled queries, though. Another thing that we do is we publish the traffic patterns to the users and then suggest them to schedule their queries in the time slots of low activity or low traffic. The other variance that we see is in the resource requirement between users. Different users from different organizations have different level of resource requirements. We used to have per user resource group, and that did not work well. It led to inefficient utilization of available resources. To solve requirement variance between users, we moved from per user-based resource restrictions to org-based resource restrictions. Through Presto Gateway, we started providing visibility to users on who in their org is consuming most of the resources. And this enables orgs to discuss usage within themselves without pulling in the platform team. If the organizations need more resources, we have a workflow to request that as well. We also wanted users to have control on speed versus resource trade-offs. We now allow users to specify query characteristics via a session property. Users can say that their query is a quick one and need very small amount of resources. We prioritize those kind of queries. Users can also come in and say that their query is resource heavy and it is okay to run it slowly. We provide higher resource allocations limits for those queries, but they are expected to run a little slower. We also provide feedback to users through a warning if a particular query could have been better served as a specific characteristic specified. For example, if someone said, "Oh, my query should be in fast lane," but actually it's consuming a lot of resources, we actually ask them that, "Hey, you should have used expensive resource group in this case." This is a snapshot of our Presto Gateway's resource groups page. Which enables users to see how much resources various orgs are consuming. They can even click through and find who from a particular org is consuming the most. To make Presto successful at Pinterest, we have invested in solving not just the system issues, but also in building solutions to empower Presto users to write better queries and understand issues with their queries. This not only helped our users to improve their querying skills, but also support load from the Presto platform team. We will continue to make progress in both these directions to make Presto users happier at Pinterest. That is all I have. Thanks for listening through the talk so patiently. We can now open for questions.
Thank you, Ashish. That was a great talk. There's a lot of questions that you've been answering as the recording was going on as well. Let's try to take another. I think there's a lot of questions about the graceful shutdown, right, and how that works. The relationship between the coordinator, the workers, when do you need to shut down the coordinator versus when do you need to shut down the workers, and how that actually works. Maybe you can talk a little bit about that.
Yep, definitely. So when we say graceful shutdown, there are two parts to it. The first is gracefully shutting down the workers, which is, as Naize pointed out, it's already supported in the open source Presto as well. So gracefully shutting down workers is something we rely on to perform when we detect the bad workers. At that point, what we do is like we start the graceful termination of those workers. That gives a little room for that worker to breathe. Essentially, just do what it is doing without taking on new tasks. And once they are done finishing up the existing task, they just like restart. And for the coordinator, we do the graceful restart, and that's majorly something we do while doing a rolling restart. As I mentioned in the presentation, one thing that we need at Pinterest for the schemas or the table definitions is the Thrift schemas, which are loaded into the JVM memory or the class path during the coordinator startup time, right? And because of that reason, and because the schemas keep changing over the period of day, we try to refresh those jars at least once a day, and usually in the night. We restart all the clusters, but we do the rolling restart of them so that we don't affect that users. So during that point, we do the rolling restart of the coordinators.
Thank you. That was helpful. A couple more questions coming in. So there's a question about multi-tenancy. You see it in the chat there. To handle, you have many organizations. You are handling all of those different organizations. How do you support multi-tenancy? Perhaps is at a cluster isolation level. Perhaps you're doing something else. Maybe you can talk a little bit about it. And then how do you provide SLAs to those organizations?
Right. That's a great question. In fact, after resolving a lot of the stability issues with Presto, now the biggest problem we spend our time on is how to do the resource grouping or resource isolation for these different organizations, essentially multi-tenancy problem. So what we do is we have a Presto Gateway layer in front of all the Presto clusters. And all the clients, they send their queries to Presto Gateway. And while they send the query, they also have to provide their credentials and their information, like which org this user belongs to. And then we also keep track of what kind of query is it? Is it a scheduled query or is it an ad hoc query? So based on these information, and on the Presto Gateway, we have a dynamic header based rule engine where we keep track of or we define rules that okay, if this for this user who is part of this organization, how much resources are being consumed on a particular cluster. For example, if a user from data org is asking to run an ad hoc query, then we check how much of ad hoc clusters resources are already used by the data org. If and we have limits specified, it's configurable, and then if we see that it's already being utilized at the peak, then we start queuing the queries. If not, we just let it go to the clusters. So we have been doing org level resource grouping, and prior to that, we were doing per user level resource groups, and that didn't work well. Org level resource groups is has been working well because we are able to identify which organizations, for example, data scientists, they love Presto, they depend on Presto a lot. So for them, it made sense that we allow them to run a little more expensive queries than some of the other organizations. So that has been working out well for us.
Right, and then there's some related questions, right, about real-time ad hoc discovery. So they may be expensive, as you said, maybe data science. There's the fast lane queries that you bypass down. Maybe talk a little bit more about that.
Right. For real time, we don't really do any real time. We do have a Druid integration. So even there, the expectation is we won't put any load on Druid brokers or the coordinators. We would just go query the segment files, similar to Twitter, I think. So the reason we added the Druid connector there was so that we can for example, different engineering teams sometimes they have to do debugging of some issue, and during that time there were some incidents caused because they were using Druid extensively, and that caused Druid to miss some SLAs for the end users. And so now those kind of use cases, which are a little more extensive than what Druid can support, they go through Presto. But yeah, the Presto use case at Pinterest is mostly around how to supporting the interactive querying as much as we can. Definitely when we started the support, we only started with queries that were supposed to be finished within half an hour. But we kept getting asked to extend that time period, essentially run more heavy queries. We are now allowing people to run up to 1 hour of queries, but I think even that is not enough for people. And then we are constantly evaluating what we can do to speed up the queries. Is it more resources, or should we go and let people run longer queries? So that's a constant process that we keep going over.
Yeah, there's not necessarily an easy answer to that one. There's a question about ETL workloads. So you see here, do you run ETL workloads on your scheduled query clusters as well? Is there a separate cluster for that? How do you manage resources for that?
Right. So for ETL clusters, we officially don't support ETL workloads on Presto. However,
not yet, right? Not yet.
Not yet. Yeah. But users love Presto so much because it's so easy for them to like interactively develop the query on Presto, and then like just to make it run on ETL, they have to transpose that onto say Spark SQL or Hive. So there are workarounds that has been developed within Pinterest where people can run them in ETL, for example, like Jupyter reports. Mm-hmm. We have some in-house scheduler service called FlowHub, Tableau. So people have started scheduling their ETL jobs there. So what we do is like whenever we have a scheduled job come in, we have a separate dedicated cluster. And we don't auto-scale up or down that cluster because ETL workloads are very predictable. Mm-hmm. So because of that, we are able to have a much better control or like a visibility into how much of resources this cluster needs or this use case needs, and we plan according to that.
Yeah, there's probably a lot of different configuration parameters would be completely different as well, query execution times, etc. So it's isolated at the cluster level is the plan for now. Great. One last question. There's a question about governance, and I think it is, it's related with how you're handling authentication, authorization, a variety of those things at the Presto level, and does the gateway take care of some of that? Or do you just push it down to the Presto coordinator? Go ahead.
Yeah, so this is something we are looking into right now. As I said, like all of our data is on S3. So when it comes to data access control, it becomes a little tricky. So because we can integrate with table access control mechanisms, but then because our data is on S3. It becomes these data sets are also accessed by other systems like Spark or Hive or MapReduce and other processing frameworks. So that unless we kind of lock down the data sets which is on S3, there is no point in securing data from Presto. So we are there's an in-house project where we have something called CVS. It's a credential vending service which gives STS token. It's an AWS STS token. So with that, you can lock down what prefixes of your S3 bucket you're giving user. So we are utilizing that to give limited scoped access to data, either via queries or through like direct access or like access from other processing frameworks.